Our next relationship is going to look at bisecting arcs and chords. So I'm going to scroll down to the second picture right here because it's really going to be the same thing for both of them. So it says the perpendicular bisector of a chord is the diameter or radius of the circle. So really what we're after out of this is that if I cross at a perpendicular in here, notice I have my perpendicular in here. If I cross at a perpendicular, that's going to cut both parts in half. So from x to this point and y to this point should be the same. And if those segments are the same, then these arcs also have to be the same measure. Okay? But again, it has to, the only way that this works is it has to cross at the perpendicular. As soon as it doesn't, then they're not equal anymore. One side will be bigger than another. So scrolling down, a couple examples that go off of this. I know that the measure of arc PQR is 98. So that is all of this. That's 98 degrees. I want to find the measure of arc PQ. Just from here over, I want to find that measure. Since I know that it crosses at a 90-degree angle, it's cutting this arc directly in half. So half of 98 then is going to be 49 degrees. Likewise, if I want to find the length of PR, notice PR is the length of the entire thing. They tell me RT is 6, but since it's crossing at the 90 degree, I now know that this arc is congruent to this one, which means that this segment has to be congruent to this one, making it 6, and then the total length being 12. Okay, again, just stressing the idea it has to cross at the perpendicular though. We can extend this idea to a problem that looks like this as well. So now I give you a stained glass window, and I'm telling you that the diameter, GH, and it shows me all the way in here, GH is 30 inches long. Chord KM is 22 inches long. I want to find JL. Switch colors here. I want to find that one right there. Okay, well, instead of, I'm just going to go back. Yep, that shows up better. I want to actually find and look at this specific triangle in here. Notice what type of triangle I drew. Right triangle. We know how to solve right triangles. We've done that quite a bit. And now this allows me to use some of the information that's up here. It tells me that chord KM is 22 inches long, K to M. We just talked about on the previous slide, if I cross at the perpendicular, that means this one and this one are equal, which means that this segment has to be 11 inches, or half of 22. I also know the length of JK. JK is a radius. I'm going from the center to the edge of the circle, which makes it a radius, or half of the diameter. In this case, I know the diameter is 30 inches long. I know that the radius has to be 15 inches. And then we can use the Pythagorean theorem to actually solve this. So we're going to say x squared plus 11 squared equals 15 squared. We've solved plenty of these before. You can round this to, does not say what to round this to, so we're just going to round it to the nearest hundredth. It would come out to x equaling 10.20 when you solve that.